Right, we're looking this session on a whole bunch of hypothesis testing, and we're going to look at a whole variety, including things like normal, binomial, the approximation, the product moment one as well, and just a whole variety to help you understand how to do these. And these questions are sent on to Teams if you're in my class, and I'm just going to show you how to do them. So I'll read it out quickly. Research has shown that drug A is effective in 32% of patients with the disease. So we've got a percent going on here. So we're thinking of success and failure. We're thinking binomial. In a trial, drug B is given to a random sample of 1,000. Well, that fits with the binomial because we've got a fixed number. So 1,000 patients with the disease, and it found that the drug is effective in 290 of these patients. So we've got a new probability of success happening here. Test at the 2.5% significance level whether there is evidence that drug B is effective in a lower proportion of patients than drug A. So it's an interesting phrase that they say, but we want to say, right, we're going to set this up. If we have to do a test, we need the null hypothesis. And with this one, it's going to be that rho equals 0.32. That's the established empirical data that we've got. And the alternative one is interesting because it says it's established whether it's effective in lower proportion. So is it lower than 0.32? And so this is where P is the probability that the drug is effective. Okay, so that's the probability there. Let's just set up our parameters. We know it's a binomial distribution. We know that we have 1,000, that's our n, and we know that it is 0.32. That's our probability of success. So we know it's a binomial. It says it's 2.5%, so we should write that out as 2.5% significance level. And we know it's one tail, because it's directional. So we set things up, and that's really important, just to set it up. And then we're going to just introduce our lovely little calculator here and show you how that all works. So what I need to do is get into my... Oh, that's not a phone. Here's a calculator. That's a phone. So you can tell I'm tired. So here we go. Let's turn it on. Let's get to menu. It's number 7. And so it's binomial distribution. It's cumulative, so I'm getting there. And it's a variable. And now what am I doing? Right, okay, well x here is going to be 290. So that's my x. My n is 1,000 and my p is going to be 0.32. So what I'm doing here is working out what the probability that it would be 290 or less. So that's where we go, 290, 1,000, and the probability of success 0.32. And it comes out as 0.0221. So the answer here is 0.0221. So that is the probability that x is less than or equal to 290. So that's what that equals. And we know that we want it as a 2.5%. So what you write here, and that's quite important, you say as 0.0221, okay, now you've got to listen to this. This is less than 0.025. Because it's less than, it means if I was to draw it like this as an illustration, I know this is normal, but as an illustration, if that was the 2.5% marker, ours is here. Okay? And that means, therefore, that you reject the null hypothesis. Okay? And then what you say is you reject the hypothesis, and you say there is sufficient, and this is the common language you'll use always, evidence to suggest, and it's kind of drug B, and then what you're going to do here, guys, is literally use the phrase that they put in here, and you write this: is effective in lowering proportion of patients than drug B. So you say is effective in a lower proportion of patients than drug A. And that's kind of the phrase you have to always write. You've got it into context, you've explained it all, and that will give you your full 7 marks. So that's how you do that one. Let's go on to question 2 and just get that one out of the way as well. Question 2 says this. It says the level in grams per millimetre of a pollutant at different locations in a certain river is denoted by the random variable x. So here, x is the level of pollutant. It's good to set things up. You get your B1 marks, etc. this way. And we said it's normally distributed. So we have a normal distribution here. Now, interesting, that's a really weird number set they've got going on there. And then it says here, in the past, the value of mu was 0.0340. So that's our past data, what mu was. And clearly here, they're going to be questioning whether that is now right or wrong. This year, the mean level of the pollutant at 50 random chosen locations. So we've got a sample going on here. We've got a sample of 50. Okay, was found to be 0.0325. Test at the 5% significance level whether the mean level of pollutant has changed. So it's not directional, it's two-tail. Okay, and what's interesting now is this is a sample. We've got a sample set. So we need to set everything up. So my normal distribution, okay, it's going to be x bar because it's a sample what, and the mean is not affected by it, and we're using the established old mean here. And now the standard, the variance is this horrible number here. So I'm going to write it out, and please don't make mistakes. There are 4 zeros there, all over, and it's 50. So I need to remember that that is my variance. This is for the population, and now this is my sample. Okay, this is my sample. So x bar here is 0.0325 because that is my sample distribution. So what I need to do is two-tail, so I need to set the thing up. I need to set it up. As always, HO is that it still stays the same, so the mean hasn't changed, it is that. And the alternative hypothesis is that there is a change, and it's two-tail, meaning that it's two options at the 5% level of significance. Now, there are different ways to solve this, and I'm going to show you 2 ways to solve it, okay? So, the first way is we want to test that whether x bar is going to be less than this mean. And as I said, we can do it in different ways. One way is to actually find what the critical value would be. If this is my normal distribution, what would the critical value be? Now the established value is more 0.34. This one is actually down here, 0.0325. Don't be tempted to call this a one-tail because the question is about that it has changed. So don't be tempted to think, oh well, it's obviously lower, it's going to be one-tail. Don't do that. What I want to try and do is find out what the critical value is. And if that value is inside the critical region, then we reject. If it's not, we don't reject. So to find the critical value, what I'm going to do is I've got my critical value, take away the mean, and then divide it here. And remember how we do this now. Because it's a sample, we use the square root of that there. 2, 3, 4, 4, 0, 9, all over 50. And it says it's at the, what percent? 5%. So it's two-tail. So if you work it out, that actually means it's going to be minus 1.96 and 1.96. There are tails in terms of our z-scores, what would be the doorways into the critical regions. So that's, because it's on the lower side, it's going to equate to minus 1.96. Now, I have done this on my calculator. What I did was, I times that by this, and then I added that value to it. So hopefully you should be able to do that at this level. So that comes out as 0.322. And now what you need to say is, well, this value here now, if this was a lower value than that, then you reject the null hypothesis. If it's higher, you don't reject it. So you've got to work out which side this is in. Okay, this is our doorkeeper is here, and this is not in that doorkeeper. That's where it would be. So what you say is, this is the value, the x bar, and you say, as 0.0325, our new value is actually still greater than the critical value, then you do not reject the HO. And you say there is insufficient evidence, I can't spot evidence at the moment, at the 5% level of significance to suggest, and then you use the words they have here, the mean level of the pollutant has changed, and that's what you'd write. And the other way to do it is to work out what the z-score value would be, and whether that is below minus 1.96 or above 1.96. The way you'd do that is you'd actually get your value that you're looking at here, you'd get that value, and you'd say it's 0.0325 minus the established what you think is the mean, or what they say is the mean, divided by, again, this rather horrible large number, and I think it's 50, isn't it? Is it 50? Yeah, it is 50. Now, again, I've done this. If you did that, you get a z-score of minus 1.66. Now, as minus 1.66 is greater than the minus 1.96, yeah, it's on this side of it all, then you do not reject, and you just keep that language the same. And don't forget to suggest a mean level. And that's how you do these ones. And I'll do another couple more videos and show you how they work as well. So there we go.